Good day once again, everybody, and once again we're back together. So we are looking at question 8, which is on financial maths. We've already done questions 1 up until 7. So please, if you haven't subscribed, just make sure you're part of the family. And we're going to be looking at the this question. And by the way, just note that we are helping you prepare for your grade 11 final. So we'll be dropping some videos and we'll give you all the information that you need. And we're going to close it out actually quite nicely with a live at the end of our week. So please look out for it. All right, let's go into it. They say calculate the effective interest rate per annum if an investment earns interest at a rate of 9.3% per annum, right? And it is compounded monthly. Now, please note this is one of your easiest formulas that you've got, and it simply says 1 plus the effective interest rate is equal to 1 plus your nominal interest rate divided by m, right? And this is to the power of m. Right, we're looking for the effective interest rate. That would be, our nominal interest rate was given as at 9.3%. So remember, you divide that by 100. So that's 0.093. And that will be divided by, now remember, they said it is compounded monthly, so that means that m is 12. Okay, and we are going to raise that to the exponent of 12. All right, so now let's find out what the effective interest rate is. And I'm going to just whip out our calculator. 0.093 over 12. Okay, raised to the exponent 12. Let me just take the 1 to the other side, so that is minus 1. So I get the effective interest rate to be 0.097. But remember, I multiply this by 100. And in this case, if I take that value and multiply it by 100, my effective interest rate would be 9.7, well, we can say 9.71%. Okay, right, so that's the effective interest rate that we have. Okay, apologies there. I'm not sure why my page keeps playing around. Okay, right, so that's our effective interest rate. Just please remember, in this case, you are just going to use that formula, and if you do that, you'll get to the right answer. Right, let's go to 8.2. They say a school bus, or a school buys a bus rather, that costs 312,000 at the start of 2023. The average inflation over the next 5 years is 6.91%, right? Calculate the cost of replacing the school bus at the end of 5 years. So in this case, please just remember that inflation happens on an annual basis and it compounds as well, right? So we're going to say, well, A is equal to P. This is 1 plus I raised to the exponent of n. The bus cost us 312,000 presently. Okay, and we know that inflation happens at 6.191%. So that is going to be divided by 100 again. So that's 0.0691. Okay, and this is raised to the exponent of 5 because they said they want to know the cost of replacing in 5 years. Right. So that's 312,000. And please try to do this with me. so that you get used to working with your calculator. Right, and this is raised to the exponent of 5. All right, so which means the cost of getting a new bus would be 435,758 rands and 80, well, let's say 88 cents. Right, so that would be the cost of replacement, right? Okay, so note that inflation happens annually, so in that case you will not need to make any adjustments in that regard. Right, so they say to us, Lwandi made an initial deposit of 23,000 into an investment account that paid an interest of 9.25% compounded quarterly. Right, this looks like one of those where we need to draw a timeline. So I'm going to do that. Right. And it always helps for you to be able to draw a timeline right at the beginning, right? Okay, so we are depositing an amount of 23,000 right at the beginning, right? And interest is paid at 9.25% compounded quarterly. Now they say after 3 years, since the start of the investment, he deposited 13,500 and interest rate changed to 8.2% per annum, compounded monthly. Exactly 5 years after his initial deposit, Lwandi withdrew 9,000. Okay. Now they say to us, calculate the total value of the investment in Lwandi's account at the end of the 5th year. Right. Now, I see later on they've got 8 years, so I'm just going to say, right, let's start with the year 1, 2, 3, 4, 5, 6, 7. That's going to be 8. Right. 2, 3, that's 4, that's 5, 6, that's 7, and that's 8. All right. So right here, right at the beginning, we are investing 23,000, right? And in this case, interest rate is compounded 9.25% quarterly. Okay, so this is 9.25%, and this is quarterly. All right. Now they said to us after 3 years, since the start of the investment, he deposited 13,000. So at year 3, there's an investment again of 13,500, and the interest rate changed. So which means the interest changed to 8.2% compounded quarterly. I don't know whether it's for the duration. Let's just keep it till 5 years. And so this is going to be 8.2%. Okay, and this is monthly. Right. And then they say to us exactly 5 years after his deposit, Lwandi withdrew 9,000. So right here, Lwandi is going to withdraw 9,000 rands. Right, and now they say to us, calculate the total value of the investment in Lwandi's account at the end of the 5th year. Right, so let's start with the first one. So we've got 2 deposits, right? And we've got a withdrawal. So let's start with the first one. The first deposit, I'm going to call it A1, right? it now endures 2 periods wherein it's going to compound. Firstly, it's going to be at 9.25%, but it's also now going to compound at 8.2% monthly. So which means the principal amount, that's 1 plus, so that's going to be I over M, that's N times M. But now it's also going to undergo that interest rate of 8.2. So that's going to be another. So remember, whatever it accumulates to also now goes through that interest rate change, right? That's another N times M. But I'm trying to show you how those are different, right? So now our investment was 23,000 into 1 plus 0.0925 over, that's quarterly, that's 4, right? And that will be 4 years. Not 4 years, rather. That's 3 years. But on each year, there are 4 quarters, right? This is multiplied by the blue period. That's 1 plus 0.082 divided by 12 into 2 years, right, multiplied by 12. All right, now that's for the 23,000. Then we have another amount which is I'm going to call that A2, right? Okay, let's take a different color for it. So I'm going to have A2, which is the other deposit. Okay, that's 13,500 that we've deposited. And now we are saying that's at 8.2%. So it only got to enjoy the growth of 8.2%, 0.082 over 12 for the 2 years. Right. Now, remember, they said to us calculate the total value at the end, right? So when did she make the withdrawal, right? They said exactly 5 years after the initial deposit, Lwandi withdrew 9,000 rands, right? So in this case, I'm assuming that she makes the withdrawal at the end of that 5 years, right? So let's calculate in this case. So which means the total value of, okay, so which means the total value, let me use a different color. Okay, so that will be A, that's not a different color. So A will be A1 plus the A2 minus the withdrawal, right? We are just withdrawing 9,000 right at the end, right? So in this case, let's do that, and we're going to do that in our calculators. 23,000, that's 1 plus 0.0925 over 4. And that's 3 times 4, that's to the power of 12. And that is 1 plus 0.082 over 4. Over 12 rather. Over 12. Remember the 12 that I that was the power there. That's the 3 multiplied by 4, which gives us the 12. And now I'm raising this to the exponent of 2 times 12. Nope. That's 2 times 12. Right, so that's the amount that I have for the first deposit. But I'm going to add to this amount now the second deposit of 13,500. So that's plus 13,500. And please, if you can't see it, just believe that you can do it in your calculator, by the way. 2 over 12, and we close this. That's yx, that's 2 times 12. All right, so we've got a total amount of 51,000, okay, but we still need to subtract that amount that was withdrawn, the amount of 9,000 right at the end. So how much does Lwandi have at the end? So that will be, please confirm with me, I've got an amount of 42,530 and, well, let's say 18 cents. Okay, right, so that's 42,530 and 32 cents. So that's what we have at the end of that 5-year period. All right, now let's look at the next question. They say, at the end of 8 years after the initial deposit, Lwandi decided to withdraw and use the money. Calculate the interest rate of the investment if the final 3 years, okay, so meaning from year 5 to year 8, if the final 3 years, or rather in the final 3 years, if the final balance was 64,487 and 24 cents and the interest was compounded monthly. Right. Now notice in this case, we know how much was here. We found it to be 42,530. Okay, I'm just going to remove this. So 42,530 and 18 cents. All right. But at the end of the term, we find that it has accumulated now to 64,487 and 24 cents. Right. So let's go for it. So we are going to say, we know it's still compound interest, the world's 8th wonder. They always say that. It's p into 1 plus I raised to the exponent of n, or we can say n times m. Right. Now, ladies and gents, what do we note? The amount has accumulated to 64,487 rands and 24 cents. But it means our principal amount was the amount that was there at the end of that 5-year term, right? We found that to be 42,530, 18 cents. We want to find out what is the interest rate in this case. So that's I divided by, said it was compounded monthly, so and in this case, in terms of our period, we've got 3 years, but in this case, we are compounding on a monthly basis. Right, now let's do some gymnastics on our calculators. So 3 times 12 is 36. So I want to write that so that you can see what I'm doing. So firstly, I'm going to divide both sides by 42,530 and 18. 42530 and 18. So this cancels with that. Okay. And now to remove the 36, okay, I am going to take the 36th root of this. 36th root. So remember, that cancels out the square, the root, cancels out the power. So I've got 1 plus I over 12. All right, now let's do that in our calculators again. Okay, I'm going to say the root of 36 of 64,487. Please just be very careful on that maths. Divided by 42,530 and 18 cents. Right, I get a value of 1.011 and all of that. So if I bring this one to the other side, it becomes negative. So I've got that 1.011 and all of that. That's minus the 1. Okay, so I'm going to say minus 1. Okay, and in this case, I've got I over 12, which is equal to that whole 0.011 and so on. Right, so I'm going to say multiplied by 12. Okay. And ladies and gents, I get a value of 0.13, let's say 0.14. Okay, 0.14. And of course, to make it an interest rate, in this case, we multiply by 100. So which means that our interest rate in this case is at 14%. And nothing wrong if you decided to not round it off as much as I did. Yeah, but either way, when you look at it, it does compel you to go to 14%. All right, in this case, that is how the cookie crumbles. I hope that this question was clearly understood, and really financial maths is really not that bad when we know what we're doing. So on the next one, we're going to be looking at probability, okay? And please look out for the next video. For now, let's leave it here. I'll see you guys again next time. Sharp, sharp.